All right, so this is topic 1 of lesson 2, and as promised in the intro, we are going to formalize your notes on the rules of exponents. And so without further ado, take a look at this little organizer I've put together. You might want to copy the chart down into your notes because we're going to fill it in. All right, so exponents, of course, that's anything, a square, cube, fourth power, fifth power, any type of power is what we're going to call exponents. We're not talking about roots right now, even though that's the material we've been covering in class, but don't you worry, it will all connect really soon. So here are a few examples of working with exponents involving just regular mathematical operations: addition, subtraction, multiplication, and division. Let's start with multiplication, because that's what we've been doing most often in class. I know I put that in the middle of the chart just because of addition and subtraction is usually first, but let's start with multiplication. So if I had, let's say, x squared times x cubed. First, let's think about what that means. What we're saying is we're taking x squared, which is 2 factors of x, x times x, and then x cubed is 3 factors of x, x times x times x, and we're taking those two expressions and we're multiplying them together. In expanded form, that would be x times x, that's our 2 factors of x for x squared, times x, x, x. And the question is, how does that simplify? We're just multiplying them together. We count up our x's and we see that we have x to the 5th. So x squared times x cubed equals x to the 5th. Here is our formal rule for multiplying with exponents. When we multiply exponential, actually, you know what, I'm going to phrase it differently. Sorry, as we multiply powers, we add the exponents. In other words, we were taking x squared times x cubed, but what we did to get from point A to point B is we took 2 plus 3, and that equals an exponent, or a power of 5, x to the 5th. So when we multiply powers, we add the exponents. All right, let's talk about division, which we also talked about in class. Let's say we had x cubed divided by x squared. Again, let's think about this in expanded form. That means on the top we have 3 x's, 1, 2, 3, all being multiplied. On the bottom we have 2, x times x. Now we can cancel, just like in any type of fraction. We see we have 2 pairs on the top and bottom that are going to cancel, which leaves us with just x over 1, or just x. The question is, what does that leave us with for a rule? Well, when we divide expressions with powers, we have to subtract the exponents. Let's look at what I mean by that. X cubed over x squared, when we did all the work out, we got a power of x to the 1, right? Or we could just say x. That's 3 minus 2. So when we are multiplying powers, x squared times x cubed, we add the exponents, x to the 5th. When we divide x cubed divided by x squared, we say 3 minus 2 is 1, x to the 1, or just x. So when we divide powers, we subtract. That's just a shortcut. I don't like to teach the shortcut first, because then it might kind of undermine our ability to understand what kind of math is really happening here. But once we've covered the math, which we have in class, and now we are again here, we can make a shortcut rule for ourselves to make our math go a little bit more quickly. Now, let's talk about addition and subtraction. When we add exponents, we can only add exponents if they are, or we can only add expressions that have exponents, expressions with powers, if they have the same power. So let's say if I had x squared plus x squared, it's sort of like saying pi plus pi, that would give us 2 pi. I have 1x squared plus 1x squared, that would give me 2x squareds. Or I could say 3x cubed minus 2x cubed. That's like saying 3 pi minus 2 pi. You would know that would be 1 pi. 3x cubed minus 2x cubed equals just 1x cubed, which is just x cubed. If I were to say x squared plus x cubed, there's nothing you can do. This is the whole idea of basically like terms, right? So we've done this a whole bunch of times. It's just sometimes when we start to add rules on, it's easy to forget the basics. So don't forget that the rules of adding expressions that have powers is that they just have to have the same power. They have to have the same degree in order for us to be able to add them together. Otherwise, you just leave them alone. Think of it just as, actually, let me go back to my blue pen here. This is really just an issue of adding like terms. Adding or subtracting like terms. Okay, that's it. Those are our only rules that we really need to think about for exponents. Although actually, I'm going to change my mind. I'm going to add in one little addendum. I have a little bit of room up here because I don't really want to put this in a whole other video. These are all the rules of basic operations of exponents. But we want to keep in mind that we could also have, let's say, x squared, and we could actually take that to a power. So x squared squared, let's say. Or we could have another one, let's say x squared cubed. We'll solve both of these so you can see the pattern. When we multiply powers, or expressions with powers, we add the exponents. But in this case, this would be the situation that I would call taking a power to a power. Power to a power. And this first expression, remember, we define squaring as just taking two factors of x squared, so it would be x squared times x squared, which then we add the powers, that would be x to the 4th. In this case, x squared cubed, that means we have 3 factors, x squared times x squared times x squared. Again, we would add them up, 2 plus 2 plus 2, that would be x to the 6th. Whoa, that just did something crazy. Let's make a 6, x to the 6th. So here's the rule for when we take a power to a power. In that case, we actually do multiply. Check this out. Here, if I have, oops, I'm in the wrong screen here. There we go. If I have x squared squared, my result was 2 times 2 is 4. If I have x squared cubed, I really get x to the 6th, 2 times 3. So a power to a power, we multiply. Oops, multiply the exponents. So let's review here. Sorry, I had to squeeze that up in the corner, but I think we got all that information in there. Rules of exponents. If we're adding or subtracting, it's just the idea of adding or subtracting like terms. We've done that a million times. Just don't forget about that. If we're multiplying exponents, because of the fact that we're taking like factors of x, so say 2 factors of x and 3 factors of x, squishing them all together, multiplying powers, we basically add the exponents to get our solution. In this case, it was 2 plus 3 equals 5. When we divide, it's the opposite. You subtract the top minus the bottom. So x cubed over x squared would be 3 minus 2 is 1, x to the 1. If we're taking a power to a power, that's a different story. That means, according to the definition of powers, that we're taking that inside information and we're making that happen as many times as the power says. So x squared squared means I have x squared twice. X squared cubed means I have x squared 3 times. So the rule is this: power to a power, you multiply. So here's the shortcut. Multiply powers, add the exponents. Divide powers, subtract the exponents. Power to a power, multiply the exponents. Write those little shortcuts down for yourself, and then put it kind of, you can turn the page or whatever you want to do. We're going to add more notes here in the next topic video, but everything we just talked about is going to apply in that next topic video.